Oh, this is John Black, Super Chemist. This is part 4. You can see it's nice white crystals or whatever. Well, maybe white yellow. So I want to pour them in here, filter it through. Now there's some crap at the bottom. I don't know if you can tell the color, but it's brown actually. I might just leave that in there. Let's do this quicker. Oh, it must be frozen. Alright, well, I'll come back when I got it all filtered out. Oh, you can see it's going now. I just wish this frit funnel, and I put water through it so I can clean it and that. Then I put it in the freezer. I must have put it in too long because the water that was still, you know, a little bit wet. It wasn't like I dried it in the oven or anything. Must have froze up there. So as you can see, it's going now. There's your stuff. I still got this. Alright, I got 100 proof vodka here. I mean, yeah, 100 proof, that's 50% by volume. I'm going to get about 100 milliliters. What do I got there? Like 96, 97 milliliters. I'm going to toss it in this crap stuff. And then I'm going to pour it on here to wash it. Nice one. Now you can see I got a bunch of this. It's kind of brownish, but there's a lot of it. And then got a little bit. You can see there's some in there. Not much though. So what I'm going to do after I get all that liquid out of there, I'm going to take this, I'm going to add some water to it. I'll put it back in the freezer and see if I can precip some more stuff out. I can see some precipping out now. I made a mistake by freezing the frit funnel because then I had to wait, and by the time I waited, you know, it warmed up. Well, if you added some more water, as you can see, I got more precip. Well, I'm going to let that drain out and we'll get it all dried up a little bit and see how much it weighs. Well, that's all of it dried up. It only came out to about 25 grams. That's, you know, definitely pure enough to do a decarboxylation. But you could, since there's only 25 grams, you could every 10 grams put a liter of water. So that'd be 2.5 liters. Boil it up and throw this in it so that it dissolves, and then you'll get like those really nice, smooth, silky, needle-like crystals like you get from benzoic acid. Because this is basically benzoic acid. It just has a methyl group attached to the benzene group, to the benzene ring. So it's basically the same stuff. I'm not going to do that because all I'm doing is a decarboxylation. So this is, you know, this will be good enough. So here's xylene. Okay, this is 120 milliliters per mole. Every mole has, you know, 120 milliliters is a mole. I use 90% mixed xylenes. I used 105 milliliters only because I didn't have 120. I miscalculated there a little bit. So I take 0.9 times 105. I used 105. I only used, but only 90% of it was xylenes. So 94.5 milliliters was how many xylenes was inside this 120 milliliters that I used. So I want to know how much of that is a mole. Like, is this a half a mole? Is this a tenth of a mole? What is that? So I take the mole, right here, the molar mass, and I take the bigger number into the smaller number of what I have, right? And I get a decimal. I move the decimal over twice. It's 78.4% of a mole that I used. All right? Now, toluic acid is 136 grams per mole. Pull this down a little bit. So I took 136 times this percentage, right? Because it's a 1-for-1 thing in the equation. So if I use 78% xylene, a mole of xylene, then my theoretical yield is 78% of a mole of toluic acid. So I times 136 times 0.784. I should be able to get 106.6 grams if everything was perfect. And, you know, you never get your theoretical yield, though. I got 25 grams. So just like up here, I want to see what my percentage is. I take the little number, the big number, divide it by the little number. 106 grams divided by my yield was 25 grams, right? I got this, I moved my decimal over, I got 23.5%. That's my yield. That's a terrible, 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 terrible yield. You should get about 50 to 55%, which is a bad yield also. But this is half of that. So I got half of a crappy yield. You know what I mean? This is terrible. One of the things I wanted to do is talk about the experiment. You notice in video 1, where I'm actually refluxing, I noticed that there's a lot of green going on there. What that green might be is N2O3, which is basically a combination of the NO gases and the NO2. Get it? NO, NO2. Get a molecule of each, you got N2O3. It's green, although it usually doesn't happen except at cold temperatures. But you know, chemistry, there's always a little bit of something going on the side that, you know what I mean, that shouldn't be happening, but does. So it might be that, I don't know, I'm just guessing. Another thing is that I did not reflux at the temperature that I should have. I really didn't even check the temperature. I should have been refluxing, I think, 145 to 150 degrees Celsius. I just refluxed it so that it went up into the condenser, maybe 2-3 inches. And it should really go up a lot higher than that. I probably didn't have it up as high. But the higher the heat you have, the more gases you're making. And they're nasty gases. What else? Okay, so I have the toluic acid. I refluxed it for an extra 55 hours. Now, I refluxed it the first time for 7.5, and then I filtered it. The next 55 hours, I refluxed it and filtered it again. I didn't get barely anything, so that was a waste of time. My whole point to saying this is maybe you only have to reflux it for 4 hours, 5 hours. I don't know if it's 7.5. I just arbitrarily stopped at 7.5 because there was a lot of crap in there. You know, I wanted to see what was up. So you might be able to reflux it for 3 hours and get the same amount. You know what I mean? In the next 4.5 hours of that 7.5 hours, I didn't make anything hardly. You know what I mean? I don't know. But next time, you know, I will try that. Another thing, DCM. I use DCM. The instructions said use ether. If you want to go to the exact instructions, you go to Google, type in dilute nitric acid oxidation of xylene to make toluic acid. Then write org synth, O-R-G, new word, S-Y-N, T-H. And then hit enter, and you'll see there'll be 3 organic synth things that pop up. One of those is it. They're similar reactions, but you'll find the one that is with xylene making toluic acid. Another thing, the heat baths. The heat baths that I did when it was just water and also when it was alcohol, you know, where I was putting the cup inside the hot pan of water. I probably should have put it hotter. You know what I mean? I should have filtered it hot also, and I didn't really filter it. You know, I didn't heat up my funnel and all that kind of jazz. Other than that, I don't really know what else to say about the reaction. Like I said, the yield was terrible. I would have been happy if I got 50%. 23.5, that's terrible. But maybe, I don't think the carbon, when I filtered, you know, using the carbon, I think I could have skipped that step, first of all. And that probably, you know, a lot of carbon in there, a lot of stuff got stuck to it or whatever. I'm sure I got a loss there. It was a waste of time anyway, I think. Also, 3 times I spilled liquid, and that, of course, made my yield go down. As a matter of fact, the stuff that I got done with, the salt, I mean the actual toluic acid at the end, it was 25 grams. I've already spilled it. I didn't reweigh it, but, you know, I'm down to 10 or 15 grams now. You know, I barely have anything doing this whole experiment. I've never spilled so much crap in my life. But actually leaving a lot of information out. But, I mean, I'm on video 4 here, come on. But I love questions. If you have any questions, mechanisms, or, you know, anything about what I was doing or whatever. Alright, there's the 3 things I put in. Here's another difference that I did. These should be doubled, okay? If you have 1x of xylene, that means you should put 2x of that, 4x of that. See how they keep doubling? Doubling 1 to make 2, double 2 to make 4. So if I put 100 milliliters in, I should put 200 milliliters here and 400 milliliters here, right? I put 105 milliliters of the 90% xylenes. According to this theory, I should go up to 210 milliliters of nitric acid. I only put in 175. So I shorted myself 35 milliliters of nitric acid. That, because that's all I had. So that also played a part in me having a low yield. You know what I mean? 30 milliliters, that's a pretty good, you know, that's like 20% loss right there. The water, I should have put in 420 milliliters. I put in 400. I don't think that would have made any difference at all. But the nitric acid, definitely, that would have cut my thing down 20% easy, my yield. This is the actual thing on Google. This is the generic equation. I really don't know the mechanics. I believe, but I'm guessing that it has something to do with the NO gas, not the NO2. The NO gas is kind of like a radical. It only has 1 electron there that's not shared. The only thing I can guess is that it would go to the xylene. These 3 spikes here are hydrogens. These 2 spikes are hydrogens. And then it would come and take a hydrogen off of there. The benzyl hydrogen would be my best guess. It's the easiest thing to pluck off of something. What happens after that to make it into toluic acid? I don't have a clue. I really don't. Anyways, you all have a good day, and always remember, science is great.